Assalamualaikum dan salam sejahtera. Now we are on 5.4 regression analysis using Microsoft Excel 2010. Okay, so in this particular section, there is no calculation needed. We just demonstrate how to use Microsoft Excel to solve simple linear regression model. Yeah. So these are the steps in using Excel, yeah, for regression analysis. So first of all, you key in the data, and take note that Microsoft Excel requires that the variables are in adjoining columns. So that means the data must be in columns and side by side to each other. Okay, then step number 2, you go to data analysis, regression, and then you enter the data range, and then okay. Okay, next. Okay, this is one of the example of the output. Okay, before that, I would like to before that, okay, in the output, you will observe there is 3 tables, main tables. One is regression statistics, where it gives you the multiple R. Multiple R is actually the correlation coefficient. R square is the coefficient of determination. So we have 2 here, R square and also adjusted R square. Yeah, normally R square is used for simple linear, whereas adjusted R square will be used for the multiple regression, multiple linear regression, where you will learn in 5.5 and 5.6. So if the independent variable is only 1, we use R square. So if the independent variable is more than 1, that is in the multiple regression, we use adjusted R squared for the coefficient of determination. Okay, standard error and observation is the number of pairs. And you also have ANOVA table. Okay, just now regression statistic, and then you have ANOVA table. Okay, this is similar to the table that we construct in the previous chapter 5.3, where we have regression residual. So in Microsoft Excel, the degrees of freedom column comes first before the sum of squares. Before this, we write sum square, the column for sum square residue for sum square first, and then degrees of freedom. Okay, and then mean square, similar. To find the mean square, we divide sum square regression, divide by 1, find the degree of freedoms, and for the mean square, we take, for the F statistic, we take mean square regression, divide by residual, so we have F statistic. So F here is the test statistic value, and significance F here is the P value, P value. So in Excel, they use significance F. Okay, and the last table is called coefficient table, where this is the value for beta node. Intercept is the coefficient is the value for the beta node, and number of hours, that mean coefficient for the beta 1. Beta 1 is coefficient for the X. Okay, so from this table, we have beta node, beta 1. So then you can construct the best linear equation, the simple linear regression, the estimated simple linear regression. Okay, linear regression equation. Okay, and then from this table also, we will know based on the p value which value is significant, beta node or beta 1. Okay, so this is the test statistics, that you can use, to test for the intercept and also for the linearity. So basically, the p value for this, from the ANOVA table is similar to this one. The p value in the coefficient table. Okay, so they are similar. They are similar, and this is the step on solving. So if the question is using Excel to solve for simple linear regression, so that is how you you use the information. Yeah, the one highlighted in yellow, this is the important value. Yeah. Okay. Okay. I will share with you on Excel on how to use Excel. Okay. Okay, in Excel, I would like to demonstrate how do we get the table that I just show you just now, okay, using um, data analysis. Yeah. First, you go to data analysis. Yeah, then data analysis. Okay, in the data analysis, you will see regression. Yeah, regression. Okay, then okay. Then you go to the input Y. In this case, Y is the mark. Okay, and the X range, that means the independent variable is hour. Okay, and then output range is where you want to. Okay, before that, labels in the first in the first row is label. Okay, so confidence interval, I think we test at 5%. Yeah, this is auto. Okay, then output range. Yeah, output range where we want to put the analysis, the output of analysis. Okay, then okay. Okay, so this is the table that you will get. Yeah, so yeah, so just a little bit so that you can see everything on the screen. Yeah. So yeah, this is the three tables that I mentioned just now. We have regression statistics table, ANOVA table, yeah, regression statistic table. Yeah, we have ANOVA table, and we have regression coefficient table. Yeah, coefficient table. Okay. So okay, so this one will determine the regression, the correlation coefficient value. Coefficient, yeah, that is R equal to 0.9448. So you can comment that there is a strong relationship between, there is a strong linear relationship between number of hours students spend and also the marks they obtain. Yeah. And then for the coefficient of determination, yeah, so you can say that 89.26, yeah, 26% of the variation, yeah, in the mark, yeah, can be predicted by the number of hours, yes, students spend to study. Okay, so similarly, yeah, so this is what we have in the slide just now. Okay. Okay, then okay, so this is what we have just now. Okay, I guess you can read through this on your own. Okay, this is the comment for each table, regression statistics table, yeah, ANOVA table, and so on. Okay, okay, and for the R value or the correlation coefficient value, you can also use this. You can also use this formula or this function inside Excel to calculate the correlation coefficient. Yeah, correlation coefficient. Okay, and then this is the explanation for the regression statistics. Yeah, and plus the explanation, the interpretation of it. Okay, and then the interpretation of ANOVA table. Okay, So ANOVA table is used to find the regression coefficient. Sorry, the significance of slope. Yeah, significance of beta node. Yeah, sorry, beta one. Yeah. So in ANOVA table, yeah, the hypothesis will be to, yeah, in the ANOVA table, the hypothesis is, yeah, we are H naught, H1, yeah, that means beta 1 equal to 0. This one, beta 1 not equal to 0. Yeah, the hypothesis testing for the slope or for the linearity test. Yeah. So using F table, you can either use critical value method or you can use p-value method. Yeah. So it is illustrated here. Yeah, on both. And then you can also in the last part, yeah, if it is significant, then you can write this equation. Okay. Okay, and then for the coefficient table, you will have the value of beta node and beta 1, the estimated value for the parameter, for the slope parameters, and also for the intercept parameter. Okay, and this is how you compare, yeah, using the significance of these two. Yeah, yeah, by looking at the p-value and for the slope and also for the intercept. Okay, so similar conclusion. So before this, make sure you write the hypothesis. Yes, so hypothesis for this one will be beta not equal to 0, H1 beta not equal to 0, and for the second one will be H naught beta 1 equal to 0, and H1 beta 1 not equal to 0. Okay. So and then you continue with the comparing the p-value and alpha. Yeah, make sure you compare with alpha, the decision, then the conclusion. Yeah, so this is the conclusion. Okay, in the conclusion, make sure, forgot to write down the level of significance. So it should be at alpha 0.05, then so on. Yeah, therefore there is a linear relationship. Yeah, so you should have this. Yeah, every time in the hypothesis testing, make sure you have that the significance level. Okay, so this is I will illustrate to you exercise 5.4. Yeah, on using Excel. Okay, first we go back to sorry, stop share first. Okay, and then I will take my Excel. Okay, I have typed in the value for hydro oxygen examples. Yeah, hydrocarbon and oxygen purity produce example. Okay, so first of all, we go to data analysis, and then regression. Okay. Okay, our input range will be, input Y range will be oxygen, that's right. Okay, and then our output range, sorry, the X range will be hydrocarbon, yeah, percentage of hydrocarbon that we fill in the condenser. Okay, label, okay, output range is where we want to place our analysis. Okay, let's say here, and then okay. Okay, so this is the same output that we have before. Okay, so we just make it smaller here so that we can see everything on the screen. Okay, so from this, yeah, you can answer all the questions stated in the examples, yeah, in exercise 5.4. Okay, so the first one, it says that state the value of the correlation coefficient. So state, so R is equal to 0.9810. Okay, so and then it says that give comment. So there is strong positive linear relationship okay, between percentage of hydrocarbon and percentage of oxygen. Okay, so that is part A. Okay, part B, it asks you to state the coefficient of determination and interpret its value. So in this case, we take R squared. Yeah, so R squared is equal to 0.9624. So the interpretation will be 96.24% of the variation in oxygen, yeah, in oxygen produced, yeah, can be predicted by the percentage of hydrocarbon used. Yeah. Okay. So that is how you interpret the coefficient of determination. Okay, and then C, you need to test the hypothesis that beta 1 equal to 0. So C, okay, we need to test for actually beta 1 equal to 0. That means this one test for linearity. Yeah, linearity test. Okay, so step 1, state the hypothesis. H naught beta 1 equal to 0. H1 beta 1 not equal to 0. And then in this case, actually, you can use p-value method. Yeah, normally, if the output is given, yeah, we require you to use p-value method. Yeah. So in this case, we take p-value. Okay, in Excel, p-value is simply the significance f. Yeah, significance s is the p-value. So in this case, it is e negative 0.5. That means this is 10 to the power of negative 5. Yeah. So actually, this is 0. I can write 1.6897. Yeah, 6897 times 10 to the power of negative 5. Yeah. So this value is much less than, yeah, much less than alpha 0.05. Yeah, therefore we are going to reject H naught. Okay, hence at alpha 0.05, there's a linear relationship between hydrocarbon and oxygen. Okay. Okay, sorry for my bad handwriting. Okay, I hope that you can read. Yeah. Okay, and then state the equation of the regression line. Okay, so for the hypothesis testing, we use ANOVA table. Okay, to find the equation, the predicted regression line will be, so this is beta naught hat, so this is beta 1 hat. So we can write the predicted equation will be y equal to 74.62 to 6224 plus 14.7055 x. Yeah, so that is the predicted line. And then it says that use the estimated simple linear regression model to predict the purity of oxygen produced when the 2% of hydrocarbon present in the main condenser of the distillation process. So it asks you to use this equation to predict the oxygen. Yeah. So it says that when x equal to, yeah, when x equal to, x is the hydrocarbon, is equal to 2%. Yeah, so what is y? Okay, so it is straightforward. So you just substitute x equal to 2 to 4 plus 14.7055 times 2. Okay, so it will give you the value is 104.0334%. okay, of oxygen. Okay, so that's all for exercise 5.4. Okay, so you can try more question from the module.